This is my user interface and user experience principle presentation, presented by Nolan Yelverton for CYEN 489 Human Factors for Cybersecurity. To begin, what is confirmation? Confirmation is one of the best techniques for error prevention and can therefore enhance usability. Confirmation provides a way to verify that a particular action is correct and intentional before it is performed. Confirmation prevents slips and mistakes, where slips are unintentional mistakes. How usability of a design can be enhanced. Don Norman's book, The Design of Everyday Things, focused on the relationship between people and the tools they utilize. Norman believed design was the most important key to regaining the competitive edge and influencing consumer behavior. Designers should bridge the gap between user and program. Experts make slips due to forgetting, and novice users make mistakes due to not understanding. To err is human. Building a safer health system in 2000 reported that as many as 98,000 people die in hospitals every year as a result of preventable medical errors. One of the main conclusions of the report was that most errors are not a result of incompetent healthcare professionals, but rather a result of bad systems and processes that fail to prevent error. Human error is inevitable, but it need not be catastrophic. A form of confirmation is dialogue confirmation. Dialogue confirmations involve verbal communication to a user, and by extension, these confirmations typically ask a question to the user. So a user will typically respond with yes or no. As seen in the user account control example, it is asking politely to the user, do you want to, when the user can respond yes or no. This confirms that a user is sure that they actually want to perform the action that's about to happen. This is mostly used for dangerous actions, which in the context of computing can include mass deleting files and giving a program elevated privileges on your machine. While dialogue confirmations are good, they should be used sparingly, otherwise users will become numb to the pop-ups and will want to just click yes to dismiss it as fast as possible. Another form of confirmation is two-step confirmation. Two-step confirmation involves a preliminary step that must happen before the actual command is completed, and this helps prevent activation of critical control on accident. As seen in the Google two-step authentication example, in order to sign into your account, you must confirm it on your device by saying, yes, that's me. An operation that requires two-step is less likely to be accidentally performed due to the user needing to actively confirm what they are trying to do. What is attractiveness bias? Attractiveness bias is the tendency to see attractive people as more intelligent, competent, and socially acceptable. There are several associated terms with attractiveness bias, such as beauty bias, lookism, halo effect, and blinded by beauty. Attractiveness bias consists of both biological and environmental factors. Some biological factors include health and fertility, such as symmetrical facial features. Biological factors are natural and true across different cultures. Environmental factors include lipstick to enhance lips, expensive automobiles, and expensive clothing. Environmental factors of attraction vary considerably across different cultures. The benefits of being attractive. Dion Burschkid and Waltster, 1972, What is Beautiful is Good, showed that attractive people are preferred over and believed to possess more positive traits and characteristics than unattractive people. They labeled these positive beliefs and attitudes about attractive people the beauty is good stereotype. Also described the beauty is good stereotype as a set of beliefs and expectations that impart social advantage to attractive people. For example, attractive people are thought to be friendlier and smarter, receive more leniency with judges, more likely to be interviewed and hired for jobs, less likely to be fired from jobs, and receive 10 to 15% higher salaries. Attractive bias in history, a good example is during the 1960 election, Richard Nixon and John F. Kennedy participated in their first presidential debate. Kennedy appeared tan, well dressed in dark colors, and had makeup to accent features. Nixon was running a fever, looked pale, had no makeup, and wore a light colored suit. This is a classic case of attraction bias, as people who watched the debate on television felt that Kennedy won the debate. However, anyone listening on the radio felt that Nixon won the debate. Don't judge a book by its cover. Attractive bias in technology. Moran, 2017, stated users are more tolerant of minor usability issues when they find an interface visually appealing. The aesthetic usability effect refers to users' tendency to perceive attractive products as more usable. People tend to believe that things that look nicer work better, even if they aren't actually more effective or efficient. Kurosu and Kashmir, in 1995, concluded from an experiment performed at the Hitachi Design Center that users are strongly influenced by the aesthetics of any given interface, even when they try to evaluate the underlying functionality. The test they performed was that the design center tested 26 variations of an ATM UI. 252 participants were asked to rate design on ease of use, as well as aesthetic appeal. They found a stronger correlation between the participants' rating of aesthetic appeal and perceived ease of use rather than the correlation between their ratings of aesthetic appeal and actual ease of use. What is chunking? Chunking is breaking large pieces of information down into chunks. A chunk is a piece of information in short-term memory. The most amount of chunks that can be processed by short-term memory is about 4 plus or minus 1. For example, most people can remember a list of 5 words for 30 seconds. However, few can remember a list of 10 words for 30 seconds. So, how can we simplify design with chunking? Chunking reduces cognitive load, and as such should only be used when memorization is involved. You shouldn't chunk information that is searched or scanned. For example, it would be very counterintuitive to break a dictionary into at most 5 words per page, as you are losing word space on the page. Familiar words and objects are easier to chunk together, so when designing a program, it might be a good idea to put buttons and other elements that have similar functions or follow a theme together in a category so a user will remember where those buttons are. The magic number 7. Miller, in 1956, the magic number 7 plus or minus 2, some limits on our capacity for processing information, introduced the world to the theory of chunking. Human working memory can handle 7 plus or minus 2 chunks of information while processing information. The ability to chunk data into smaller sections gives the individual a way to remember more information. For example, your short-term memory can recall about 7 words, but if you group words into chunks of 4 similar words, you can recall 28 instead. Chunking in action. Give yourself 5 seconds to look at the letters below, then look away and try and remember as many of the 18 letters as you can. Not easy, right? Below are the same letters, but with the order reversed and grouped to make meaningful 3-letter strings. Now try after the letters are grouped into 6 groups of 3. You could even take it a step further and group the words into themes. There are various chunking memory techniques that people use. A popular way to use chunking for improved memory is by taking the first letters of a set of words you want to learn and making another word from those letters, so an acronym. For example, STEAM is science, technology, engineering, arts, and mathematics. The next technique used is making up phrases known as acrostics. An acrostic is a bit like an acronym in that it takes the first letters of the words you're trying to remember, but rather than making a single word from the first letters, you assign each letter a new word to make a memorable phrase. For example, EGBDF is every good boy does fine. And another way is to chunk to learn related numbers. In the example below, rather than learning 12 total numbers for the 3 years, you can reduce the work you need to do by just remembering the first date, so 1776, and then just remember how far from that date the other 2 years are. So from 1776 to 1781 is 5 years, and from 1781 to 1788 is 7 years. It's much easier to remember a total of 6 numbers. Thank you for listening to my presentation.